out here is that if you look closely here, look at the rated voltage here, right? This is not a floating value. This is essentially a class as well. And every single physical quantity in GDM is represented as a point quantity, right? And what that means essentially is that every single physical quantity will have a magnitude and will have a unit associated with that magnitude, right? So when you're defining these, what you will need to do is be able to define a point quantity, an appropriate point quantity. For example, for rated voltage, you might have to create an instance of voltage, define the magnitude, and define what the unit is. And the advantage here is that, like, client packages can actually do the unit conversion, and there is then always consistency. I don't have to figure out what units the user used. I can always convert them to appropriate units that I want and then do the calculations on my end. So the code would never break, if that makes sense. All right. So talking about physical quantities, I just wanted to go over some of the caveats here. So all the physical quantities can be imported from gdm.quantities, right? So in this example, I've just imported a variable called active power. The way I would define active power, as I said, would be by first defining the magnitude and then defining the appropriate units here as well. If I print this, what you'll see is I have 800 kilobar, right? All of these quantities have to method, and what that allows me to do is I can call the to method on var. If I want to convert from kilowatt to var, I can just say convert this to var, and I'll end up with var here, right? And this is what I meant when I said there is support for unit conversion. So for example, if in Cadet I'm building out some optimization problem, and then I'm expecting vars every single time, I can do this conversion beforehand before I input these values to my algorithm, and make sure that my inputs to my model are always going to be consistent and things will not break. Right. This quantity also supports both lists and numpy arrays as well. So if I define, for example, 400, 200, 200 as a list here, you'll see that when I print this out, this is a list, and I can use the to method here as well to do appropriate conversions. Again, if you have any questions, please stop me at any point in time and I can answer your questions. In certain cases, additional validation might be performed as well. So for example, a PV system can only provide active power and it cannot consume active power, right? So we check for that as well within the validation phase. So when you're building out a PV system, for example, in GDM, it would require you to set the active power as a positive active power quantity. Positive active power, as the name suggests, it assumes that you can only have an active value. So if I try and use a negative value here, it is going to throw an exception saying that this value must be positive. So the user knows there is a very explicit error saying that you cannot use a negative value here. Please use a positive value. Right? So we do validation of these kinds of as well. One limit of validation, it's not a limit, but essentially something that need to be noted. So unit validation does not occur until the quantity is added to the data model itself, right? And what do I mean by that? So if I import positive voltage here, the expectation is I can only set voltage here, but that is not the case. So if I try and create this model is going to get created, right? There isn't an error when I run this cell here, right? The error is only going to be raised when I try and set this rated voltage here, right? So in this example, I'm setting this rated voltage to this rated voltage here. This is the variable that I created. And when this model is created and the pydantic validation is run, only then you see an exception raised, and this is going to be very, very explicit, saying that the unit must be compatible with volt. What you set was amperes essentially, and that is incorrect.
Adam?
Yeah.
Do you support per units?
We support dimensionless units, yes, but not per unit, because we don't know what the unit is, right? Like so we just say that they're dimensionless essentially.
Got it.
Yeah.
So all real units have to be absolute.
They have to be absolute, yes. Okay. SI quantities. All right, any other questions?